we get this is trivial solution. Okay, so here if b is not equal to 0, then this equals to 0. This equals to 0 means you have a sine of root lambda plus h of root lambda cos of root lambda, that equals to 0. Okay, so if you solve that and this is a sine by cos, that equals to tan, so this becomes tan root lambda, that equals to minus of h, and this is root lambda. Okay, so this is the equation. Okay, so here you have to find the what is the eigenvalue here, because here both side is lambda is okay. So here root lambda, and here is also root lambda. So here we can write this is root of lambda. Okay, so here we put suppose if we take root lambda is suppose n variable alpha, and here if we take this root of this equals to this thing, so your alpha is this thing, and suppose your okay, so and the variable suppose xi, that equals to minus of h, and root alpha is the root lambda is alpha. So if we take this thing, so our above equation reduces in the form of some xi equals to, because this is xi, that's equals to tan alpha. So this equals to tan alpha. Okay, so this is your equation. Okay, and here we are interested to find what is the value of alpha here, because if we find the alpha one, then we can find lambda one for alpha 2, that is lambda 2, and so on. Okay, so here two equations holds, and okay, so here if we plot this and try to find what is the okay, what is the value of alpha here. So if we draw, this is your suppose this is your alpha, okay, and this equals to tan alpha, that equals to xi. Okay, so this means if we take this thing, this is your axis, suppose this is the xi. Okay, and here we are trying to find what is the xi equals to tan alpha. So here tan alpha, so you know that at a different point, this means this is your 0, okay, and here this pi by 2, this tan pi by 2 is infinite. So here this line, and here this is pi, okay, and this is suppose 3 pi by 2, and this is 2 pi here, okay, and so on and so on. Okay, so if we plot this graph, and similarly here this is minus pi by 2, and here minus pi, and so on. Okay, so you know that this at pi by 2, this is your asymptote here, so this becomes the graph of this curve is like this is your tan alpha. Okay, and here at pi, tan pi equals to 0, and 3 pi by 2 becomes okay. So this is like okay. So now at pi, so this is the graph of this tan alpha. Okay, at here pi by 2, this becomes 0. The 3 by 2, this becomes 0, and here okay. So this is your graph of this tan of xi. This is the graph of tan of xi. Okay. Oh, tan of alpha. Is it tan of xi? Is it tan of alpha? This is your angle alpha. Okay. So this is tan alpha. And the second equation is, what is your second equation? Second equation is this xi equals to minus of h, this thing. Okay, so second equation is okay. So this is the okay. So this is the graph of minus of, this is the equation of xi equals to minus of h alpha. Okay, this is the graph of that. Okay, because this is alpha, so this is for any slope that equals to h. Okay. And here, if you are interested to find at 2 pi, this becomes 0 here. So okay, so here this graph is like this. and here this type of graph. Okay, so what is the intersection point here? This is the intersection of point. First one is this thing, okay, and second one is this thing. So here, if this equation satisfies xi equals to tan alpha, and where xi equals to minus of h alpha, so it means tan alpha equals to minus h alpha. The solution of that is basically this intersection point, which satisfies both curve. So this is your alpha one, and this intersection is alpha 2. And similarly for the next one, if we draw here and this extend this line, your intersection point is alpha 3, alpha 4, and so on. Okay, so here you can write here what is your uh, the equation holds at for different value of alpha 1, alpha 2. So we can write here, okay, so we can write here basically the two equations, that is two equations holds here. So the two equations holds at different alpha 1, alpha 2, alpha 3, and so on. And what is our eigenvalues? So our eigenvalues are basically, if our eigenvalues is lambda equals to alpha square. So this means our eigenvalues are that lambda is equals to alpha 1 square, alpha 2 square, alpha 3 square, and so on. Okay, and what is your corresponding eigenfunction? So what is your corresponding eigenfunctions? So here the eigenfunctions are, what is the solution? Solution is b sine root lambda x. Okay, so this is your solution for different value of that. Okay, so what is your solution is? Solution is basically sine of root lambda I x, root lambda I x, and here this is and here of course y equals to b here. We can write here b. This is the solution, and for I equals to 1, 2, and so on. This is your eigenfunction. This is your eigenfunction, and this is your eigenvalues. Okay, so okay. So similarly, you can find for you can also examine for also check for what about alpha equals to 0 and alpha is less than 0. Okay, so this part you can do yourself and try to find what is the non-trivial solution for in both cases. Okay, so here we only solve for lambda is greater than 0. For lambda equals to 0, what happens? And for lambda less than 0, what happens? If you are able to find the non-trivial solution, so just tell what is the solution. And if you are not able to find the non-trivial solution, then the only result for this boundary value problem is this thing. Okay, so this is the another type of boundary value problem. So in next page we define what is a green function, and then we try to solve the problem which is depending on that green function. So in next page we define what is green function. So in next page, so Green's function. So if we consider the boundary value problem, consider the boundary value problem, and which is of type, if we write in this operator ly, that equals to minus of fx, and where this x is lies between in interval a and b. What is operator here? What is L here? So you know that L is d over. So these homogeneous boundary condition. Okay, so what is your green function? So the Green's function, which is usually defined by g x of psi. Okay, this is green function where this x and xi belonging on that interval. So where this x and xi, this is belongs to that interval. In this x and xi, this is xi with the real one and x with the variable. So in the real line, suppose this is so this thing, and suppose xi be the here. So if x is belonging to that part or x is belonging to that part. Okay, so this is your function. This is function such that is such that it says that rules, and the first one is this is solution of the homogeneous differential equation, and that is a L of y that equals to 0. So this is solution of a homogeneous equation, that is Ly that equals to 0. Okay, and it satisfies the boundary condition at A and boundary condition at point B. Okay, so this satisfies at both boundary condition. Okay, and here you take this. This is the solution of this. This it means fx equals to 0. We make this boundary value problem in the form of homogeneous. Okay, so here your fx part is 0. So this is the solution of this thing, homogeneous boundary value problem. Okay, and second thing is that our this gxy is basically continuous function. It is continuous function of x and xi, and but its first and second derivative is are continuous everywhere except at this point child. Okay, so in next page, the second condition of this green function, the second condition of this function defined on next page. So we go to next page, and here what is your second condition? So second condition is this g of xi is green function is a continuous function is a continuous function is continuous function of x and xi for x and xi belongs to this closed interval a and b, but uh, it's first and second derivative, but its first and second derivative are continuous everywhere in this domain, that is a and b, except at the point psi. So except at psi. Okay, and third condition is this function is not continuous at x equals to psi. So this means what is the discontinuity at this point? So the jump discontinuity. So the jump discontinuity of of this j, this is given by d over dx of green function this j. Either you can write g prime. Okay, so you can write g prime here. G prime xi, and here this is x equals to xi minus to x equals to xi plus. This discontinuity that equals to 1 over p of xi. What is p? P basically px or p be the coefficient of your y double prime. आप चाहें तो यहाँ आप ले सकते हैं what is p here. So px is a coefficient of y double prime. So here from that this thing. Okay, and such a green function g of xi, this function is called, this function gxi is called the green function. This is your green function for the operator, and that operator is L. Okay, so what is the solution of your given boundary problem? So why we find this green function? So by using this green function, we are able to find the general solution of at your non-homogeneous boundary value problem. Okay, so therefore the solution of हम किसी की डेरिवेशन हम नहीं करा रहे हैं, हम डायरेक्ट आपको रिजल्ट दे रहे हैं क्योंकि काफी लंबा ऑलरेडी बहुत से थ्योरम हो चुके हैं. So the solution of the non-homogeneous equation, non-homogeneous equation is given by, and the solution is equals to y. What is your solution? Solution is equals to a to b, and here we write the green function we have already found by here, and this of f of xi. F of xi means where our operator is defined like that, L of y equals to minus of fx. So here we take from that non-homogeneous part, that is a function of x, and here we make this function in terms of xi, and then we integrate this with and putting here x equals to a to b. Okay, so from here you have this f of xi. Okay, so the general solution of this non-homogeneous differential equation is given by this formula. Okay, so this is the basic definition and the theory of this green function. Okay, so here we are quickly we solve the problem which is depending on this green function. Okay, so कैसे हम ये सारी चीजें हम यूज करेंगे अपने एक प्रॉब्लम में. तो हम एक प्रॉब्लम ले लें इन नेक्स्ट पेज और ये सारे फॉर्मूले हमें लेकिन याद रखने होंगे कि सारी चीजें हमें यूज करनी. नेक्स्ट पेज okay, so we take a green function, simple problem. Okay, so we take a problem. Okay, so if you have to find the green function, पहले तो आप green function now find करें, find green function for say phi double prime equals to minus x. Okay, and what is the boundary condition? So boundary condition is given this and this equals to 0. Okay, so find the green function. Only we are interested to find the green function. Okay, not the solution. Okay, तो हम ग्रीन फंक्शन भी इसमें फाइंड करेंगे और फिर इसका सोल्यूशन भी फाइंड करेंगे. ठीक है, तो ग्रीन फंक्शन जब हम फाइंड कर ही रहे हैं तो हम इसका सोल्यूशन भी फाइंड कर लें. तो आप इसमें हम ऐड भी कर लेते हैं ग्रीन फंक्शन एंड सोल्यूशन भी कर लेते हैं, सोल्यूशन फॉर दिस. ओके, अब ठीक है. तो हम यहाँ पे लिखें कि अगर हमसे अब जनरल आपकी जो डिफरेंशियल इक्वेशन है दैट इज एल वाई that equals to minus of fx. Okay, so you know that this is a general non-homogeneous boundary value problem. Okay, and what is the p? आपको p का यूज है. p क्या है आपकी? p is the coefficient of y double prime. हाँ, यहाँ पे p की वैल्यू क्या है? 1, और यहाँ फंक्शन की वैल्यू क्या है? minus of fx. तो only function is only x here. Okay, so here अगर आप चाहें तो यहाँ आप लिख सकते हैं कि what is px. So px equals to 1. Okay, px equals to 1 because the coefficient of y prime that equals to 1. Okay, and what is fx is here? Fx equals to x here. Okay, so now comparing with this standard form, you have this P and F you have find out. Okay, so firstly we have to find the what is the solution of homogeneous equation. So what is the homogeneous equation? So homogeneous equation, because green function is the solution of the homogeneous function, and homogeneous function क्या है आपका? So this is a y prime that equals to zero. We make here this right hand side equals to zero. This is your homogeneous equation. And what is the solution of this? And solution is, you already know what is the solution is. This is ax plus b. This is the solution of that, x equals to b. Okay, so here you put here what is your green function. So here if we take y1, okay, y1, this function of x, basically if we take this is a1 of x, because y equals to x plus b, this is a solution for all x which belongs to a and b. Okay, so this x a1 and say b1 for x is lies between these two. Okay, because you know that this is the your interval, and that interval is 0 and 1. This interval is given 0 and the boundary value problem 0 and 1. And here this is a point in arbitrary point psi which belongs to that 0 and 1. And of course x is also belongs to that. So either x is belonging to this side, x is belonging to that side or that side. Okay, so either x is less than xi or x is greater than or equals to that. Okay, because x and xi both are belongs to this 0 and 1. Okay, so if this is the solution when x is less than xi, okay, and suppose the second is a2x and plus something arbitrary constant b2, this is the solution when xi or we can write here x is belonging to that interval. This means xi less or equals to x less or equals to 1. So this means x belongs to that side. Okay, so now we can find the solution. So now assume that this first one satisfies the boundary condition, and also second one also satisfies this boundary condition. So first one satisfies the condition at zero. So this means y1 0 equals to 0. So this equals to 0 equals to y1 0, and that equals to a1 of x. No, this a1 into x. Okay, sorry, here okay, थोड़ी जल्दबाजी में so this is a1 of x and a2 of x, because this is ax. Okay, so here a1 into x equals to 0 and plus b1. So this implies b1 equals to 0. So b1 equals to 0. So okay, so what is your finally what is your y1 x equals to, when b1 is 0, this is simply a1 x. Okay, so assume that second one, so assume that this y2, because from when x belongs to this thing, when x is lying between this thing, so this boundary condition holds, because if x is lying between this portion, so only this boundary condition holds. And if x is belonging to that portion, so that boundary condition satisfied. Okay, so इसलिए हम second को हम लेंगे जो कि हमारा boundary condition किसमें ले, इस interval में. Okay, so this second satisfies this boundary condition. Okay, so this y2 of at 1, y2 of this y2 of 1, this equals to 0. This means a2 of 1 plus b2. So this implies b2 equals to minus a2. So what is your solution? y2 x, this equals to, if you're putting here b2 equals to minus a2, so this is equals to a2 x minus 1. Okay, so this is your y1x, this one, y1x, this is solution, and y2x, and this is solution. Okay, and you know that your solution is continuous at x equals to psi. This means this solution y equals to x. This is the solution. This solution is continuous at that point at x equals to psi. Okay, so this means you write here. What is x equals to xi? This means these two are continuous. So y1 and y2 are same at x equals to xi. So when this is a1 xi and this is a2 xi minus 1, and these two are same. Okay. So in next page, in next page, in next page, okay. So the solution means y1 and y2. This is continuous. Solution is continuous. Oh, solution is continuous. Solution is continuous at x equals to xi. Okay, so your solution green function is continuous at x equals to xi. Okay, means y will be the continuous. So this implies what is y1 at xi that equals to y2 at xi. So this implies a1 psi and a2 psi minus 1. Okay, so suppose this is equation number 1. Okay, and also from green function, you know that the derivative of your green function, the jump discontinuity of this is g of x xi, this is from x equals to xi minus, so x equals to xi plus, this equals to minus 1 by p of xi. Okay, and here px, since px that equals to 1, so this implies what is the value of p xi, this is also equals to 1. So this equals to minus 1 by 1, that is minus 1. Okay, so this is your d by dx of that thing. Okay, so here you know that what is your green function. So if g of xi that is defined by y1x, and another function is y2x, and this is your function when x belongs to 0, and this means xi minus interval, and this is when x belongs to xi plus. Okay, so this is interval. Okay, so then at x equals to xi, this equals to y2 prime x minus y1 prime x, that equals to minus 1. Okay, so this means here the derivative of that means at that y plus means xi plus means this thing is y2 prime, and minus if you're solving this derivative of that, then minus this means g prime, the differentiation of that of when x is belonging to g plus xi plus means when x is belongs to xi plus is y2x. Okay, so in that interval y2 prime, this thing minus this means when x is belongs to xi minus, then y1 prime. So now from this equals to minus 1. From using this we get this thing, and what is the y2 x and y1x? So you know that y2x and y1x is defined by this a1 xi and a2x, a1x and a2x minus 1. So अगर हम इसको differentiate करें, this becomes a2 and this becomes a1. So this implies you get a2 minus a1, that equals to minus 1. Suppose this is question number 2. Okay, so if we solve this 1 and 2, if we solve 1 and 2, so we get what is the value of a1 and a2. Okay, so here what is your function, green function? So this green function is defined by this y1x. Okay, so y1x is basically what is your y1x? So y1x is a1x, and what is your y2x? y2x is a2 x minus 1. But here we have to find what is the value of a1 and a2. So on solving these two here, if we take this and putting here, okay, so this equation is a1 psi minus a2 psi, that equals to minus a2, and here this is minus of a1 plus a2, that equals to minus 1. Okay, so if we're adding multiplying by xi in this equation, so here we this is xi, and this equals to minus of xi, and this adding these two, so this okay, so this becomes what is the value of equation 1 if we adding, okay, now क्या वैल्यू होगी इसकी, इक्वेशन फर्स्ट है हमारा, ओके, तो फिर राइट a2 xi minus a1 xi, that equals to plus 1, a2 xi minus a1 xi, that equals to plus 1, and here a2 minus a1, that equals to minus 1. Okay. So a2 minus a2 so what is the value of a1 here? So a1 की वैल्यू इन टर्म्स ऑफ a2 यहाँ लिख सकते हैं, कोई दिक्कत नहीं है, तो ट्राई करें. सो आई थिंक a1 is 1 minus psi and a2 is psi. Okay, so the green function is a solution of this a1x means okay, so x 1 minus psi. What is a2? 1 minus x into a2, that is psi. So this is the solution, and when x lies between this interval and here this psi x, this thing. So this is your green function. This is your green function, and you can find easily what is the solution of that. Okay, so what is the solution of non-homogeneous के लिए solution का निकालना हो, तो next page पे चले and try to find a non-homogeneous solution जो हमारी boundary value problem है, that is L of y, that equals to minus of fx. Okay, so this non-homogeneous boundary value problem की solution क्या होगी, तो solution, you know that the solution of above boundary value problem, which is defined by y equals to a to b here, of course axis belongs to closed interval ab. So the solution of that equals to g green function, the solution of your homogeneous part, and this f psi and d psi. Okay, so in this problem, this solution yx, that equals to here boundary condition are 0 and 1, and what is your green function? So green function we write here gx of psi, and what is f psi here? So f psi is here a psi. Okay, here fx in your problem, fx equals to x, so this implies what is f psi? So f psi is psi. So here you can write this g psi. So now we also, what is your green function? The green function is defined by this formula. This is x 1 minus xi when x is lies between 0 and xi, and the second one 1 minus x xi when x is lie between psi and 1. Okay, so here we this break into the 0 to x, Okay, because this is the interval of x, so 0 to x, g of x xi d xi plus x to 1. uh, okay, and in this part, in this term, this is your x which is less than your xi. Okay, तो यहाँ पे x ऐसा आपको xi लेना है। यहाँ पे आपका xi जो है, ये xi की इंटरवल जो है वो 0 से x, xi इस पोर्शन में, इस पोर्शन में xi जो है दिस इज लेस देन और इक्वल्स टू x। ओके, तो यहाँ पे आपको देखें कि xi हमारा कब मेरा x से छोटा है, तो xi मेरा x से छोटा कौन सा, ये दिस पार्ट में। तो यहाँ पे आपको इंटीग्रल में यूज करना होगा 0 टू x दिस फंक्शन 1 माइनस x xi into this xi d xi एंड प्लस इन दिस x टू 1 में हमारा यहाँ पे हम देखें तो यहाँ पे xi जो है, ये xi मेरा x से क्या है, बड़ा है। इस केस में xi जो है दिस इज ग्रेटर देन x, वो सारे xi जो कि x से हमारे बड़े हों, तो वो xi जो कि हमारा x से ग्रेटर है, x से बड़ा है, दैट इज दिस फंक्शन। This function is x1 minus psi, and here psi d xi. And then solve this integral with respect to xi and putting the limits, you find the general solution of non-homogeneous equation. Okay, so if we try to find this, so the solution of